we'll be describing different ways to request real-time and historical market data from the API. We'll build on the previous lessons, which discuss connection in the simplest hello world programs, and we'll create some new simple programs just to show how data can be requested both in real time and historically. So to start off, there are several API functions which provide streaming market data. The first, which we'll go into more detail today, is just rec market data. And this function provides streaming updates several times per second for a particular ticker of any values which have changed. Another function is called rec real-time bars. This function provides 5-second updates of high, open, high, low, close values over that 5-second period and continually gives updates in real time as they occur. Another function which is similar is called rec historical data. This function can now also provide updates in the same way, but it also has the ability to provide historical data before giving updates of streaming real-time data. When it does this, it'll give updates of unfinished bars as they occur in real time before giving a completed bar. And finally, we have rec tick-by-tick data, which is the newest of these functions, and provides streaming tick-by-tick data for every trade or quote change that occurs. So unlike rec market data, which will just give updates several times per second, rec tick-by-tick data will actually give every individual tick if that level of granularity is needed. However, one of the differences in rec tick-by-tick data is that it does have more stringent limitations in terms of how many tickers can receive streaming data simultaneously. In each case, the first step would be to define a unique contract object, and that object would then be passed into the corresponding function. So for every individual instrument that you'd like to receive data for, one of these functions would need to be called. So next we'll go into speaking more about rec market data in particular, since that is the function most commonly used. So rec market data has fewer limitations than some of the other functions, and that you can make requests for at least 100 streaming tickers in your account at the same time, and that number can potentially be increased. The data you get with rec market data will correspond to data in TWS watch lists, such that if you were to find the right column header for a TWS watch list, it would match exactly the data that's being returned to rec market data. So with rec market data, it also has the option of different market data types. These market data types correspond to whether you receive delayed, frozen, or real-time data. All the other functions for streaming data only work with real-time data. So the 4 different data types that we have would first be live streaming data. This is the default, which the API will be in unless a different data type is specified. Then we have frozen data, which is usually used after a market close to receive the last available bid or ask price. So if you're in live streaming data, after a market closes and you request data, you'll just get usually a -1 value for the last available bid or ask. If you actually want to see this last value, as is shown in TWS by default, you need to first switch to the frozen data type. Then we have the delayed data type. This is if a user doesn't have market data subscriptions for a particular instrument for which subscriptions are required, which is any instrument other than, say, Forex and bonds. Then you can receive delayed data still by first switching to the delayed data type before invoking rec market data. And finally, there's delayed frozen data, which is a combination of types 2 and 3. So that would be if you don't have market data subscriptions and the exchange is closed, you'd like to see the last available bid or ask value. Then you could switch to data type 4, which is delayed frozen data. So in all the cases, before calling rec market data, the function which you'd want to use is rec market data type to switch the type of data if you'd like to use something other than the default, which is the live streaming data. Okay? And then, as discussed in previous lectures, to retrieve streaming data, like anything else in the API, you would need to have some basic components. That would first be a class which derives from both a client and a wrapper, so that it can inherit functionality in those classes. You would need to override wrapper callbacks, which handle return data to functions such as tick price, tick size. And then before requesting any data, you would need to call connect. Okay? Next, we'll go into a short sample code, which can just show a demonstration of how to request market data for Apple stock. Okay, so here we have a very simple sample script. If you watch the previous lessons, you'll see it's very similar and has all the same parts. The only difference really is in the function call which we invoke, and also in the wrapper functions which we have overridden. So in this case, we still have overridden the error callback. This is used for any notifications when you first connect to let you know the market data farm is okay. It is also used if there are any actual true error messages, such as if you request live data for an instrument, which doesn't have live data for that particular username used to log into TWS. And of course, we have a class which derives from both eWrapper and ND client. So just like in the previous session, first we would connect. After we create this object, which derives from those two classes, then we need to create a contract object. This is an example of a contract stock, but a contract object can be defined for any type of financial instrument in an IB system by using a different combination of parameters. Here we're doing a smart route request. So that means we want aggregate data from all available exchanges where the Apple stock instrument trades. So that would be, for instance, ARCA, BATS, NASDAQ, NYSE, and others. And we define the primary exchange just as where it's listed in case there's an ambiguity with another contract, say, overseas, which has the same ticker symbol, AAPL. Okay? And you also notice, just like in the previous lecture for simplicity, I omitted the step here, which really would be in a production code, where you wait for the next valid order ID callback before continuing. So after we've defined the contract object, first thing we're going to do, which would be necessary in an account which has delayed data, such as a demo account, would be to switch the market data type to 4. So what that will do is if the user doesn't have market data subscriptions, it will switch the delayed data type. Otherwise, if the user does have market data subscriptions, that actually won't have any effect. And next, we actually make the actual function call to rec market data. So the parameters for this function call are first the ticker ID, which is the first field, and that's just used to specify which data coming back matches up with which data request in case you're doing many simultaneously. Then we have the actual contract object, which we just defined for Apple stock. The next parameter is called a generic tick list, and this is just comma delimited numbers, which correspond to what we'd call generic tick types if you want other types of data. So there are many other data types other than what we've called default tick types can be sent back. The default tick types, which are sent back if it's just an empty string, would include things like the bid value, the ask value, the last value, the open, the high, the low, the close. All those values are default tick types, so those are always sent back. If you want other types of data, for instance, like auction values, or you'd like Reuters fundamental values, financial ratios, then those could be defined by having a different generic tick type. The next two parameters are for snapshot data. If you just like to receive a one-time snapshot, instead of false, this would be true. So there are two different types of snapshots. One is called a regulatory snapshot, and the other is called a streaming data snapshot. A regulatory snapshot is when you have a very specific market data subscription called the U.S. Regulatory Snapshot Subscription, in which case, if that's set to true and you have that particular subscription, each snapshot request would be returned for just a penny apiece. And in a snapshot request, what it would do would just give you exactly one update for values like the bid, the ask, and the last. Whereas if you want streaming data, then you would continually receive those in real time. The next parameter is the streaming data snapshot boolean, which is also false in this example. That boolean is used if you do have the correct market data subscription for streaming data, but you just want to receive a one-time snapshot and not streaming updates. So then you could set that to true in that case. So that's all we need to do. And after we call rec market data, of course, we'll always have to have this run loop, just like in the previous example. And what that will do will process messages in the queue and send them to the corresponding functions in eWrapper. That would include tick price and tick size, which we've overridden here. There are additional callbacks, which could be overridden. They aren't in this example for the sake of simplicity, but that would automatically be invoked depending on the type of data being returned. So for instance, there's a tick generic callback, there's a tick string callback. And those are used for different things like timestamps of the last trade, which aren't sent back to tick price and tick size. So tick price will just receive callbacks of price values. So things like the bid or the ask, the bid price or the ask price, be sent back to tick price as they occur in real time. Tick size will just correspond to size change updates. So if there's a change in the size of a quote, that will be sent back to tick size. And all we've done in this example to override these functions is just to print the resulting data to the screen. Of course, in your own code, you'd likely be doing something different, such as processing the data or saving it to disk or something else. You'll notice the different parameters in the callback. So we have this request ID, which matches up with the same ID here. So this would be 1 in this example. Then we have the tick type, which refers to the type of data. There are quite a few different tick types. So for instance, there'd be one tick type for the bid or one for the ask. And then we actually have the price, which is the actual value of the current time in the market. And we also have some attributes. The attributes tell us different types of data. So for instance, like if it's a future, and it's a pre-open quote, and there would be a specific attribute for that would be sent back. And that's defined in more detail as well in the documentation. Okay, so I'll just run this a simple sample program so we can see the results that occur when you request data for Apple stock. And I do already have TWS running, I should mention, of course, and it is listing on the same socket port, which should be socket port 7497. We can just double check that here if we go into the global configuration menu. So we've enabled ActiveX and socket clients, which is necessary for the API. We've also let it be on socket port 7497, which is actually the default for paper trading accounts. So it should be listening on that socket port. Sorry there, we'll try running again. Okay, and so you can see this is just the data being returned. This will match exactly those same fields in a TWS watch list. We'll just pause the output here so we can take a look. And you can see through the callback, so this would be the tick size callback, for instance. One callback, you have the type of data being returned, which is the bid size. You have the ticker ID, which was ticker ID 1. That lets us match it up with the initial request, which also used the ticker ID of 1. And then we have the current size quote, which would be 5. So for instance, this would say there's a change in the size quote for the bid to the value of 5. And the next would say there's a change in the ask quote size to a value of 1. And then we also have different types of tick types sent back as well, such as the volume. This is just the daily volume sent back. With the last size, which is the size of the last trade, and many other types of data, such as the bid price or the ask price. So that's just an example of how to request market data for Apple stock using the API. So in order to receive live data, which won't be enabled by default for most instruments, there are several requirements. First, a market data subscription must be added through account management for that particular instrument. In general, it will depend on the instrument type, which market data subscription is necessary. For instance, there is a subscription for NYSE stocks, another for NASDAQ stocks, and so the correct subscription must be added to the account. Exceptions to this are, say, for Forex and bond data, which are free and enabled by default in all accounts, or CFD data, which is free as well. So in those cases, there won't be a necessary market data subscription. Usually that would need to be added because it will already be enabled in the account. It's important to note as well that from the API, even to receive historical data, it's also necessary to have a market data subscription. That's because from the API, historical data is from the data that's first available all the way up to the present time. And the last 15 minutes are defined by the exchange as live data, so the live data subscriptions are needed for that period. This is unlike in the TWS chart, where you can make a chart, at least up until 15 minutes ago, of data, even without a subscription. Whereas in the API, it's always necessary to have that market data subscription and live data in TWS before historical data can be received. So as we touched on previous lecture, where we used rec contract details as an example, we have to first always define a contract object to invoke any function which requests real-time or historical data. So there are different ways the contract object can be defined. For each type of instrument, such as a stock or future or an option, and there are different ways of doing it. It just depends on your personal preference. As long as the contract is uniquely defined, that object can be passed into one of the corresponding market data functions. And that same object then, once it uniquely defines an instrument, can also be used in other functions as well, such as place order. So you'd be able to recycle that same object. And then it's important to note, if you're interested in combo or spreads, these are also defined as a single object. So they're defined very similarly to other types of contract objects and then passed into a function such as rec market data. So if you wanted to request market data for a spread, you would have a single contract object and a single market data function call, as opposed to, say, having multiple function calls for each contract within that spread. And if you ever need to find the parameters which define a certain instrument, say a stock or a future, any other type of instrument, a very useful tool is Trader Workstation itself. So if you have an instrument in a watch list in TWS, you can just do a right-click on the name of that instrument, on the ticker symbol, and then choose an option Financial Instrument Info, and then choose Description. And that will show a complete listing of all the different fields which define that contract. Those will be the same fields that could be used from the API. So next we'll discuss how to request historical data from the API. And some important limitations to keep in mind about historical data. For common stocks, typically you receive about 5 to 10 years of data available, though it will depend on the instrument type. For most other instruments, it can be less than that. For futures, for instance, expired futures are kept for 2 years before they are removed from the database. So if you wanted a future, say, expiring 18 months ago, that would be available. From 3 years ago, it would not be. And then for options, as soon as an option is expired, it's removed from the database, so that data is no longer available. And that would also be for futures options. And by the way, this is also for Trader Workstation or any other trading platform, so it's not something specific to the API in the IB system. When using the function rec historical data, some other important limitations are that if bar sizes of 30 seconds or smaller, so say 1 second or 10 seconds, are used with rec historical data, there's a limitation that no more than 60 new requests can be made in a 10-minute period. Also, for bar sizes which are larger, say a minute or larger, if a very large amount of data is requested, say if you try to do 5 requests for a year of minute bars, that data will be throttled depending on how busy the server is, such that it can take longer to be returned than if you were to make a smaller request. So in general, in your API program, it's best to design it so that it doesn't request unnecessary bars, which might cause the data longer to be returned. Okay. Well, next, we'll go into a simple example using rec historical data to show the open, high, low, close bars that can be received for a 4x instrument. Okay, so this is a very short sample program. If you've watched the earlier lesson, you'll see it's very similar. Really, the only different part here again would be that we've overridden a different callback in eWrapper, in this case historical data, and also we have a different function call here, rec historical data. So this is the corresponding function eWrapper, which matches the function in a client called rec historical data. And then we first define a contract object, just as we did in the previous examples, because that would be one of the parameters in our function call. So in rec historical data, the different fields are, first there's an ID, which uniquely defines the request in case you have multiple simultaneous requests pending. That can be just any positive integer. Next, we have a contract object, which we defined as in the previous lesson. In this case, we're defining a contract for a 4x instrument, which is just a Euro-USD cash pair. That will always be on the ideal pro exchange. And for 4x, we always have the security type of just cash. Okay. Next would be the end date. So in this case, we'll just use an empty string, which just means an end date of the present. So right now, we're requesting data up until the present moment. So if you want a different end date, say from a week or a month or a year ago, that's where you would input the date. Okay. Next is the duration of data. In this case, we're requesting 1 day of data. So the abbreviation for that is 1 space D. Then we have the bar size, which is 1 minute. So here we're requesting 1 day of 1 minute bars. Next is the type of data, which tells us which type of data you'd like to receive. For instance, if you want bid data, ask data, midpoint, trade data where it's available, this is where you would define the data type. For 4x, it's important to keep in mind there isn't trade data available from interactive brokers, so you would have to use either bid or ask or midpoint here. You wouldn't be able to use, say, the last traded price. Okay, and so then the other functions we have would first be include RTH as abbreviation for include regular trading hours. So if we just want data from regular trading hours only, which applies more to some instruments than others, then this would be a 1. Another case would be a 0 if you want all available data. Finally, we have this parameter is the format of the data. So there are 2 different formats you can receive. One would be the Unix time, and the other is the more normal time with the year, the month, the day. So this would just determine which of those formats you want the time stamp to be in when data is returned. There are more details about that in the documentation. And finally, we have the keep up to date field. Keep up to date just tells us if after we receive the historical data, if we'd like to receive streaming updates. In this case, we'll just use false. So data will end after it's requested and all data is returned. It won't give us streaming updates in real time. And then finally, the last parameter will always be an empty list. It's reserved for internal use. So after we make that function call, then we again have to enter the run loop. And the run loop will just, as before, process messages in the queue and send it to the corresponding function in the wrapper. In this case, that function is called historical data. After calling rec historical data, they will be passed back to a corresponding function in the wrapper. In this case, that function is just called historical data. Then in historical data, we'll have a separate callback for every bar of data. So that is every object which has an open value, and a high, a low, and a close, as well as a volume. So you can see in that bar object which you receive back, those are all the individual fields, which in this case we're just going to print to the screen. In your own program, you likely would do something different with that data. So the other fields, in addition to the open, the high, the low, the close, as well as the timestamp, which is the date field, we would also have a volume. So if this is trade data, there would be a volume reported. We have the count, which is the number of individual trades. Say you might have a volume of 10,000, but a count of 100, meaning there are 100 trades total with a volume of 10,000. And then finally, the weighted average price over that bar. So we'll just run this example to see the results, which will just look at the last day's minute bars for the last day for the Euro-USD pair midpoint values. Okay, so if we look at the return data here, as before, the first thing that occurs is that we have these callbacks, which are just notifications that we connected OK, and then we're connected to the market data farm and the historical market data farm OK. And then we finally get the callbacks, and there will be one separate callback for every bar of data. So every one of these corresponds to 1 minute over the last session of the Euro-USD pair, and it gives us the open value, the high, the low, the close over that time period. In this example, since it's not a trade data, it's just for the midpoint, the volume and the count and the VWAP would all be -1. Those are only received when we request a type of trade data and not the bid, the ask, or the midpoint. Okay, and then if we scroll down to the very bottom of the data, okay, we can see this goes up until the current time. So this would be right now, the date and the time. Okay, and so that's how we would request historical data. A simple example in the API. Okay, and then just for further thought, very commonly in Python, pandas are used. So if you want to, say, store historical data, it's very simple and convenient to use a pandas data frame. That's a bit outside the scope of our lecture today, but it's something to keep in mind looking to further. If you'd like to look into the official documentation for Panda data frames, those can be very conveniently connected to the historical data returned from the API. Another important note, which is something that we receive a lot of questions on, is what types of data are actually included in the historical database at Interactive Brokers. So this wouldn't just be for the API, but also applies to any other trading system, such as Trader Workstation, where historical data is shown. So candlestick data in the Interactive Brokers historical database excludes certain types of trades that usually occur away from the NBBO, and so that can be misleading because it's not the type of trade price which you would usually receive for a regular order type. So this includes things like average price trades, odd lots, or derivative trades. All these types of trades would be excluded from trade data when it's returned in candlesticks. So because of that, because it excludes certain types of trades, the volume information which you receive from Interactive Brokers data source, you will notice can vary from volume received from other sources, which do include those trade types. So that concludes our lesson for today on requesting real-time and historical data from the API. I hope you'll join us for our next lesson. We'll discuss placing orders.